Standard form is a method by which we can take numbers with a lot of digits and then just write them in a slightly shorter way, just for the sake of efficiency. Now, most of the questions you're going to have on this topic are then going to be about either turning an ordinary number into standard form or taking a standard form thing and turning it back into an ordinary number. The method is basically this. We're going to take our first digit, so the first one here is 1000, that's just going to be a 1. Then it's going to be times 10 to however many digits there are after the first one until, if it is there, you reach a decimal point. So in our case, this will be times 10 to the 3, because there are 3 zeros afterwards. And in this case, that makes sense, because 10 times 10 times 10 of 10 cubed is 1000, and just times by 1, keeping it 1000. In other examples, though, if we do 50,000, the first digit is going to be 5, so you'd write 5. And then there are 1, 2, 3, 4 digits afterwards. So you'd write 10 to the 4. Now, when you get to numbers that have more than one non-zero digit at the front, however, we're still going to be just doing a single digit first of all, so it's still just going to be 3. However, if there is anything else afterwards that isn't a 0, what you're going to do is put a decimal point and then write them here. So here would be 3.14. And then when you're doing your times 10 to a power, you're including this 1 and 4 again. It's still any digit that's after the first one, in this case after the 3. So here there are 1, 2, 3, 4, 5. So it'll be 3.14 times 10 to the 5. Just expanding this the other way then, if we were to start with standard form, we've got 9.2 times 10 to the power 6. You'd start by writing your 9 and your 2. And then there's going to be 6 digits after the 9, including this 2. And just anything after the 2 is going to be a 0, because we have no information for it. So the 2 is the first digit, then second, third, fourth, fifth, and sixth. So you'd have 9.2 million there. But what if, instead of being some number that's like 1,000, 100, tens of thousands, instead of a decimal below 1? So on the right here, we've got 0.1. Well, again, we're going to start by writing our first non-zero digit. In this case, once again, that's a 1. And then times 10. However, this time, the power is going to be a minus, because we're beyond the decimal point. And it's going to be how many zeros are in front of that first digit you gave. So in this case, there's only 1 0. So it'll be 1 times 10 to the power of minus 1. Then again here, with our 0.007, our first non-zero digit is that 7. And times 10 to the minus, and there are 3 digits in front of it, 3 circles in front. So it'll be to the minus 3. And then again, as with our 3.14 times 10 to the 5 on the left-hand side, here, if we have digits after our first non-zero one, we're still just going to do that first digit, in this case the 8. Decimal point 0, 3. It doesn't matter that this is a 0 here. We're now going to include it because it is after the first digit, and there is another non-zero digit afterwards. So 8.03, and once again times 10 to the minus, and there are 1, 2, 3, 4 zeros in front, so to the minus 4. For then an example of just expanding once more, we've got 6.5 times 10 to the minus 2. This time we're going to start with the zeros, as you can kind of tell from these previous ones. So it's a minus 2. So the first 0 obviously going to be on its own. There's going to be a decimal point. There's going to be 1 more. And then you would write your 6 and your 5. Okay, so that's just a matter of how we can get from ordinary numbers to standard form and vice versa. What if you then wanted to manipulate these standard forms? So for instance, what if we had 4 times 10 to the 7 times 8 times 10 to the 9? Okay. Now, what you can do is, well, if it's a calculator paper, you can just put it straight into your calculator, no problem. Your calculator will potentially give it as an ordinary number if it's small enough. You'd need to then convert it back into standard form, assuming that's what the question's asking for. But if we were to do this manually, if it was a non-calculator or you just chose to, one method would be just to expand these numbers as they are. So you could write a 4 followed by 7 zeros, and 8 followed by 9 zeros, and times them together that way. If it was addition, actually, that would be even more straightforward, because you can then just do the regular adding them or minusing them from each other. But with the multiplication, we can actually do this a little bit easier if we are keeping the standard form, where we can say that, okay, well, 4 times 8 would be 32. And by the powers of indices, or the rules of indices, if we had 10 to the 7 times 10 to the 9, the powers are just going to add together, making this 10 to the 16. However, this isn't standard form. As we've been doing above, standard form requires only one main digit. Anything else would have to go after a decimal point. So right now, this 32, that's not good enough. It will need to be 3.2, but if we've done that, we're then going to have to times by another 10, if you think about it, to get back to the same place. So this will now rise to 10 to the power of 17. Well, if you're all happy with that, let's see how you get along with an example of your own, which is going to combine each of these concepts here, so both turning ordinary numbers into standard form and then combining them together. For this, you're probably going to want to think about your rules of indices. So let's say that we had 2 million times by 0.06. So first of all, I'd like to turn that into standard form and then have a go at timesing them together. If you just want to pause the video here to go have a go for yourself, and then press play again when you're ready to compare. Alright, so first of all, turning these into standard form. With each of them, we only have one non-zero digit, so we can first just go straight to saying this will be 2 times, and there are 6 zeros afterwards, so 10 to the 6. And then this is being timesed by, and then it's just a 6 times 10, and this will be to the minus 2, because there are 2 zeros in front. Right. Now, when we come to timesing them, we can just do the number by the number, then the 10 power to the 10 power. So 2 times 6 is going to be 12, and it's going to be times 10. Now, as I said before, when we're timesing these like 10s to powers together, you can just add the powers. Well, in this case, technically that would be 6 add minus 2, or just 6 minus 2, which is going to be 4. And of course, that's not in true standard form. That would be if it was 1.2. Yet, if we're moving the decimal point 1 to the left, you're going to have to times by one more lot of 10 in order to make it the same thing. So that will now be 10 to the 5. Alright, now that we've covered the main principles, let's look at an actual example question. So we've got 3 parts here. The first couple, as you can see, are like what we've been doing. So here we have 8.2 times 10 to the 5. Well, we will take our 8 and our 2, because this is a positive power, there's nothing to go in front. And now this 5 digits after the 8. The 2 already counts as 1, so there's 1, 2, 3, 4, 5. So 820,000. Then for down here, we'll start with the first non-zero digit, that's the 3. Anything that comes after will become the 0.76. And it's times 10 to how many zeros are in front? 1, 2, 3, 4. So to the minus 4. But as for part C, as we can see, that's now getting a little bit more complicated. We're going to be combining these standard forms again. Just like when we were multiplying, if you're not doing this with a calculator, if it is a calculator paper, you can just plug it in. But if we're not doing it with a calculator, you're doing it manually, we can just look at the numbers themselves and then the 10 to the powers individually. So this would give us, to start off with, 2.3 over 4.6. Now, if you may notice, 4.6 is double 2.3, which means this is actually going to be the equivalent of a half, or because standard form is using decimals, we'll say 0.5. As for the 10 to the 12 divided by 10 to the 3, well, again, if we just think about how indices work, if we're dividing through like this, if timesing was to add the powers, Dividing is going to minus, so 12 minus 3 is going to leave us with 9. So we have 0.5 times 10 to the 9. However, this is actually just as not good as what we had above on the previous page. We need it to have a single digit and then a decimal point. Yes, but that doesn't include a 0. We don't want a 0 in front. We'll want this in the form of 5 times 10 to something. This time again, we're going the opposite way. We'll be timesing by 10 rather than dividing by 10 to get the 0.5 into 5. And if you've already times by 10, you only need to times by one fewer than this now. So this is going to drop down to 8, making that the value of this division in standard form.